All right, my name is Anna Steffi. This is for Physics Distant Learning 172, and we are group 19.
My name is Zach Barnett, and I'm in group 19.
My name is Alana Jadwalis, and I'm in group 19.
I'm Zolin Jia in group 19.
This is for lab 3, the momentum principle and constant force. And we've been working on this for a while, and we're here to just do the discussion questions. So on screen, as we can see, it's based on the example above, come up with the initial design of an experiment. I believe somebody had like a weighted cart. Who was that?
That was me, but I actually didn't end up really messing with the weight too much in my trials.
What'd you do instead?
Well, that's the thing, is I was trying to figure out exactly why we were supposed to, or even if we were supposed to do multiple trials and compare the different trials. I just did the one.
Did you end up doing 2 trials?
That's what I was saying. I'm not sure. I honestly wasn't sure if I was supposed to or not. I did. I just did the one.
I did, just because I thought that was the way I was going to validate it. Does anyone else want to share their initial design?
For mine, which I didn't end up doing, but my initial design, I had my independent variable as like the initial velocity, but then I didn't end up going with that because I thought that would be harder for me to like measure and put into GlowScript. So I ended up going with yours, PETA, where you changed the angle of the ramp. And so I did like 3 trials for that.
Oh, I see. I did like 2 trials. Interesting. And Gia, did you do any?
Yeah, I'm using the gravity as the constant force, and then do the ramp to measure just the velocity change, since the mass is constant as well, like the independent variable.
Okay, I see.
Yeah.
And then for the next discussion question, share with your team the data collected and discuss the analysis of the results. I don't have everybody's data in here
yet, but I guess you guys, I can talk about the data here, and you guys can also share your screen if you want, and so we can talk about your data if you want it, or you could just tell me what the graphs have shown you probably. Anyway, I increased the height of the ramp from 1 inch to 4 inches, and what I should be able to do if the momentum principle is valid is I should be able to change this position, and which the higher it is off the ground, the more potential energy it will have. And as it falls, that's why it will accelerate like faster than if it was only like 1 inch off the ground. I should be able to put these positions into the principle and get there and predict that at 4 inches it will have a greater speed than it was at 1 inch, and that's what my graphs show. Like these lines are very, very flat, and this line has like, it went very fast. That and these bumps, just like we had learned, was it bumping back off the box that I had to stop it. So I would have stopped the time before it had time to bounce back, because one of my assumptions is that I'm not going to assume that that happens. That's just going to stop. And does anyone else want to share their screen or talk about their data?
I guess since I did the same experiment, my graphs look very similar, except I think I had the cart turned with like that axes like weird. So it's like the reverse, but it still shows the same idea of having like a greater velocity and energy, or like force when it's at a higher height.
Yeah. Anyone else?
I mean, I don't know if I have much different to say about my data, but it looks similar. I think I had a much longer ramp than you guys. So it's a little bit easier to read just because the graph is more exaggerated. But overall, it follows the same trends that yours does.
Yeah, and for my data, it's the same. Like I built a very long ramp with a very long box of my keyboard, and the data will be easier to read, but it's basically the same.
Okay, interesting. And then we have our last discussion question. It says, we're going to compare the experimental graph versus the simulation graph. What are the differences and assumptions? And this last discussion question asks about those comparisons we made in the assumptions. So did anyone like want to talk about how their graphs compared?
I would probably talk about the accuracy problem I have. Well, I do have some calculation. And it seems to me that it is really hard to result totally matches, because the in the Go script they are using like P equals to MV, those formula, and it will be a ideal result. And for actual experience I'm doing, there are many measurement that you can't be so precise. For example, I'm trying to measure the angle of the ramp like with the ground, and I use the cosine and sine, those things to measure with the ramp height and ramp base. But when I was measuring the base length of the ramp, and it is hard to measure very clear whether it's, for example, it is 1 meter or it is 1.1. Like there are those things that are affecting the accuracy. And also when the car is moving down, it's not like a totally straight line. It's not an actual straight line. It could be very variable. Like it could be changing a little bit, like to the right or to the left. It's just many small things that are affecting the accuracy of the final data.
Yeah, I agree. I think I had like a lot of similar problems with doing my calculations as well, especially since my data doesn't really look like my GlowScript data. And again, all the measurement stuff you talked about, and when I released the cart, because I tried to release it and not push it or anything, I've always wondered if I released it like too slow, or there was like drag on my fingers, or if I released it on like the exact same spot that I had last time. And again, like if my ramp wasn't like perfectly like solid, if it would like bend a little bit as like cardboard, or if the cardboard wasn't completely flat, it would move a little bit that I wouldn't be able to like perceive, but the graph knows.
Yeah, I agree with both of you guys. I think the biggest inaccuracy kind of comes in with human error is a one thing. It just if we're not putting the car on completely straight or whatever, but also mechanical error with the car itself. Also, it's assuming it's a frictionless surface, which it isn't, but you know, it's pretty close. So I don't think that's an unreasonable assumption to make either.
I was gonna say, like the car itself that we use probably isn't weighted even on both sides either, especially through like shipping being like jostled a lot. It probably will just like inadvertently have to veer to one side, where we will lose energy to like some other portion. To whereas like the glow script kind of assumes it's like one solid mass, like moving down. And then the last thing I noticed was I just forgot that my cart was gonna bounce back from the box, like I said earlier. And so the final graphs do not show that at all.
Yeah. Yeah, my graphs just show it like increasing forever. Well, not forever until like the end of the time interval, but
Forever.
yeah.
All right. I think we got through it all, guys. Thanks.